Now, trick to Captain Brain. These 7 primitive unit cells are very important because sometimes the question comes from them on the basis of the edge length, or you may say side length, or on the basis of the axial angle. So today here I am give you the trick on the basis of the side length. Now I think all of you heard the name of Mother Teresa. So we get here T of Teresa and Mother, and I do a small change here. I replace E from the C. Okay. Now here T stands for triclinic. T stands for triclinic. M stands for monoclinic, and O stands for orthorhombic. Orthorhombic. Now here all the 3 primitive unit cells have unequal side length. Now A is not equal to B, and B is also not equal to C. Okay. Now that one T is stands for tetragonal, and this one H stands for hexagonal. Now here in both the primitive unit cells, to A and B side length is equal, but C is not equal. Okay. Now we replace here E by the C. So C stands for cubic, and R stands for rhombohedral. Okay. Now both the primitive unit cells, the sides are equal. All the sides are equal. Okay. Till now clear? Okay. Now these 7 primitive unit cells are subdivided. These 7 primitive unit cells are subdivided on the basis of their possible variation. On the basis of possible variation. Okay. And now these 7 primitive unit cells become 14, and these 14 primitive unit cell, 14 primitive unit cell called 14 various lattice. So we are going to discuss the 14 various lattice. Okay. So let's start. Now here the first is cubic lattice. Now how many types of possible variations shown by cubic lattice? There is 3. First is primitive, second body centered, and face centered. Okay. Now what about the sides of the cubic? That all the sides, side A, side B, and side C are equal to each other. And what about the angle? Now alpha equal to beta equal to gamma equal to 90. Means all the sides are equal to each other and all the angles are equal to 90 degrees. Okay. Now the next one crystal is tetragonal. There are 2 possible variations. Tetragonal possible variation, 2 primitive and body centered. Now here side A and side B is equal, but side C is not equal. And if we are talking about the angles, angle alpha, beta, and gamma equal to 90 degree. Okay. Now the next one is orthorhombic. Orthorhombics have 4 possible variation: primitive, end centered, body centered, and face centered. Now here all the sides A, B, and C is not equal to each other, but all the angle alpha, beta, and gamma equal to 90 degree. Okay. Now the next monoclinic. There are 2 possible variation: primitive and end centered. Here if we are talking about the side, all the sides are unequal to each other. A and B is unequal, but angle alpha and gamma is equal to 90 degree, but beta is not equal to 90 degree. Now the next various lattice is hexagonal. Only one possible variation, which is primitive. Hexagonal, only one possible variation, which is primitive. And here side A is equal to side B, but side C is not equal. Now about the angle alpha and beta is equal to 90 degree, but angle gamma is equal to 120 degree. Now the next one is rhombohedral. Here the possible variation only primitive. Now all sides equal to each other, but angle alpha, beta, and gamma Now next one is triclinic. Possible variation is primitive unit cell. All sides are not equal to each other, and alpha, beta and gamma angles are also not equal to each other and not equal to 90 degree. Okay. Now the next one is, now we are talking about the number of atom in a unit cell. Now we know that crystal lattice is made up of the unit cell, large number of unit cells, and we know that unit cell, in unit cell, lattice point occupy a space. Lattice point what? Lattice point, it may be a particle, it may be an atom, or maybe a molecules. Okay. Now the question is that how many space is occupied by a particle in a unit cell. So we are here calculate the number of atom in a unit cell. We know that unit cell is of two types: primitive unit cell and centered unit cell. Okay. And we also know that here centered unit cell is divided into face centered unit cell, body centered unit cell, and centered unit cell. So in all the four we are calculating the number of atoms. We are calculating the number of atoms in a unit cell. Okay. So now number of atoms in a unit cell. First is simple primitive unit cell. What is simple primitive unit cell? That all the constituent particles are present at the corner. Okay. It means here the constituent particles are present only at the corner. So you can easily make a simple primitive unit cell. How? Now take 8 balls and attach each of them in a square, in a cubic form. So you will get something like that structure. And here, as I told you, that in simple primitive unit cell, that all the constituent particles are present at the corner. Now here, okay. So to find the number of atoms, that how much number of atoms are present in a unit cell, you have to use a knife. Now take a knife and cut the structure of the 8 balls into a cubic form. Then you will get something like that structure. Okay. So to find the number of atom in a unit cell, first in each unit cell have 8 atoms on its corner. Now you have to count them: 1, 2, 3, 4, and 4 are downward, so all are 8. Okay. Now, so the total, we have to calculate the number of atom at one corner. So how to calculate it? So the total number of atom in one unit cell. Now, how many number of how many number of atom in each unit cell? There are 8. There are 8. And now, how many number of atom in one corner? At one corner, there is 1 upon 8. We can find out like that. So total number of atom in a unit cell, we have calculated something like that. Total number of atom in each unit cell, and number of atom at one point or one corner. So there is equal to 1. So here in simple primitive unit cell, only one atom is present. Okay. Now you all have a question, sir, how did this happen? So you can get the experiment by oneself. Get the 8 balls and attach in that manner, and use the knife and cut them, and you will get something like that structure. When you get this structure, now attach each part of the ball into a square form, into a ball form. Then you will observe that how many number of atoms present in a unit cell, in a simple primitive unit cell. Okay.